When we look up at the pitch-black darkness of the night and dive into the sky, how inclined are we to think that the universe is just a serene and peaceful blanket of stars draped over us, right? However, one of the most unsettling mysteries that science and humanity face lies right behind this calm and elegant facade. Think about it. There are approximately 200 billion trillion stars in the observable universe. This is a massive number that the human mind is completely helpless to grasp, a number that even words are insufficient to describe. Worlds revolve around the vast majority of these stars, and billions of these planets are located in those delicate, perfectly balanced habitable zones where water can remain in liquid form. Countless candidate homes with the right size, the right chemical composition, and the right conditions are drifting in that boundless darkness of space. The universe had an immense, mind-boggling time of 13,800,000,000 years for life to sprout, intelligence to evolve, and magnificent civilizations to be built. Yet, when we turn our most advanced listening devices to this cosmic ocean, the only thing we hear is, literally, a deafening silence. Beyond the thin borders of our world, there is not a single radio broadcast, not a trace of cosmic engineering on a massive scale, nor the whisper of another intelligence. If you enjoy these kinds of calm journeys that change the way you perceive reality and reach into the secrets of space and time, and if you haven't already, you might consider joining us and supporting this journey. Your little support helps these philosophical discoveries in the depths of the dark cosmos reach many more curious minds. Now close your eyes. Leave your mind beyond those worldly troubles and physical borders, and prepare yourself completely. We are beginning. If you'd like, let's start with our familiar cosmic neighborhood, our own home, the Milky Way galaxy. Just within this spiral alone, between 100 billion and 400 billion stars are spinning. Each one of them, just like our sun, is a potential source of life, providing heat and light to the different worlds revolving around them. Moreover, the Milky Way is just one of an estimated 2 trillion galaxies as far as our horizon can see. When we dive into this mathematical ocean, we feel it in our bones that we are no different than a grain of sand in the face of these massive scales. The data provided to us by the Kepler Space Telescope proved that planets are not rare jewels in space. On the contrary, they are ordinary products of cosmic clouds. Most stars have at least one planet, and many consist of multiple systems. Rocky planets, similar to Earth, are not an exception, but rather seem to be the rule of the universe. Conservative estimates made just within our own galaxy indicate that there are tens of billions of potentially habitable worlds. Despite this incredible potential, whispered to us by the numbers, reality acts as if it's mocking us. On cosmic scales, we cannot see any trace of engineering, intelligent radio frequencies crossing the depths of space, or massive structures. Apart from this pale blue dot we call Earth, we don't have the slightest proof of intelligence or consciousness. It is this great contradiction that gives birth to perhaps the most disturbing question in human history. Right at that dark intersection of science and philosophy, with the universe having such suitable conditions and a massive time frame to produce life, could the fact that intelligent beings haven't left a single trace just be a cosmic coincidence? Or is this deafening silence the echo of a much heavier, much darker truth that we are not yet aware of? In light of this dizzying data we have, the actual question we should be asking is not whether life exists elsewhere. The real question, the simple yet incredibly terrifying question that bugs minds and causes sleepless nights, is this: where is everybody? Ever since the very first day we began expanding our perceptions as humanity, we have been waiting for the universe to somehow make its presence felt or for civilizations to leave traces in the void of space. If life is a statistical rule, the dice should have been rolled countless times in this massive cosmic ocean. Our expectations were that the sky should be like a bustling metropolis full of interstellar communication signals, energy traces of civilizations, or massive structures. However, the view we see resembles an abandoned, desolate, and extremely deep void, while our telescopes patiently scan space. They can only catch the background radiation, the rhythmic pulses of dead stars, or the natural noise of galaxy cores. As nature continues its own harmony, encountering the artificial signature of an intelligent mind seems impossible. This silence is not merely a lack of data. It is the most insurmountable, coldest wall we hit in our struggle to make sense of our own existence. The fact that we have nothing else to hear but the echo of our own voice amidst that infinite crowd of stars might actually harbor a much deeper and more mysterious secret than we anticipated. The contradiction between this crowded universe promised to us by numbers and this freezing desolation we observe is known in the scientific world as the Fermi paradox. Think of the Italian physicist Enrico Fermi. In 1950, he was having an ordinary lunch with his colleagues at the Los Alamos National Laboratory. The topic was the possibility of extraterrestrial life and faster-than-light travel. The scientists at the table were doing rough mental calculations. A heated debate was going on about the probability of Earth-like planets forming, the chance of life sprouting, and the odds of this life reaching an intelligent level. All the numbers at hand were whispering that intelligent life should be ordinary and very common in the universe. At a certain point in the conversation, Fermi stopped, looked around, and asked that simple yet staggering question that shattered all those calculations: where is everybody? To truly feel the weight of this question, we must look much closer at universal clocks, those massive cosmic calendars. The Milky Way galaxy we are in is about 13.6 billion years old. In contrast, the Earth we stand on and our own solar system have only existed here for 4.6 billion years. This massive time difference means this: while our sun was just a cosmic dust cloud, other stars had already formed elsewhere in the universe, and planets had already taken shape around them. There must have been worlds born billions of years before us. If civilizations had sprouted on those planets, they might have survived for a duration so long that we can't even imagine. Just imagine a civilization only 1 million years, or even a few 100 million years, older than us. The technological leap they could possess would be much, much sharper than the difference between our invention of the wheel and our smartphones today. Even if a tiny fraction of these civilizations had developed space travel technology, they would have had an immense amount of time to cross interstellar distances, even traveling at a very small percentage of the speed of light, at the slowest possible pace. Even if transitioning from one system to another took thousands of years, colonizing the entire galaxy would only take them a few tens of millions of years. A few tens of millions of years might sound like an eternity to human history. But compared to the age of the galaxy, this duration is as brief as a cosmic blink of an eye. Therefore, a civilization with enough time should have long crossed those borders and spread everywhere. The traces of their expansion, engineering marvels, or massive structures covering stars, should definitely be noticeable from some corner of space. Yet, when we look at our horizon line, we can't see a single footprint indicating that intelligence has spread across the galaxy. We have actually been listening to the sky for a long time to break this silence. Since the 1960s, SETI, or the Search for Extraterrestrial Intelligence, has been scanning the sky hoping to find an artificial radio signal among the stars. Those giant radio telescopes in different corners of the world turn their antennas to the depths of space, 2 specific star systems, and 2 cosmic dust clouds. They listen with great patience across a wide frequency range to catch any sign that might come from an intelligent source. An artificial signal would immediately reveal itself amidst that natural chaos of space. It could be squeezed into a narrow bandwidth or remain fixed at a specific frequency. It could have a structure that repeats itself at regular intervals, with its amplitude or frequency altered to carry information. None of the natural cosmic radio sources, like pulsars, quasars, or active galactic nuclei, produce smooth signals with these characteristics. Nature's noise is irregular and chaotic. However, A signal designed by a civilization would stand out and shine through that chaos with its smooth structure. Yet, despite scrutinizing the sky for over 60 years, we have nothing to show for it. There are no clear narrowband signals, no modulations carrying information, nor any broadcasts repeating regularly from the same location. As far as we can understand, the universe is calm, silent, and completely devoid of artificial sounds. The only things echoing in the depths of the cosmic ocean are the birth and death rattles of stars, the gravitational waves of black holes, and the only sign of intelligence reaching the interstellar void is merely those desperate calls emanating from our own planet. Everything else is buried in a deep and incomprehensible silence. Throughout our cosmic quest, we haven't been completely without moments that occasionally made our hearts race, whispering that we are not alone in the dark. The most famous false alarm in the history of science was recorded in 1977. For instance, astronomer Jerry Emmon was examining data coming from the Big Ear radio telescope at Ohio State University. On the night of August 15th, the telescope caught an incredibly strong and narrowband radio signal, lasting exactly 72 seconds. The signal was so striking, so unusual, that Emmon excitedly wrote, "Wow!" with a red pen on the computer printout. This mysterious frequency was coming directly from the direction of the Sagittarius constellation. It was exactly the kind of flawless sign that researchers looking for alien intelligence were hoping to find. It had a narrow bandwidth, its amplitude was very high, and it was broadcast on a flawless frequency that would be least affected by the interstellar medium. However, a continuation of this exciting moment never came. The signal never repeated again. We listened to the same region over and over again with different telescopes for years, for decades. We hoped to catch another whisper in that dark corner of the sky. But that mysterious signal was never heard again. This situation, passing unconfirmed and unrepeated, makes it completely inexplicable. We will never know for sure whether it really came from an extraterrestrial intelligence or if it was merely earthly interference, caused by a reflecting satellite or an airplane. This is the most frustrating part of space exploration. Even when we catch an interesting anomaly, it flies off into the darkness before we have a chance to examine it in detail. That if you want. Let's look at the other side of the coin, at the sounds we emit ourselves. As humanity, we have been leaking our own existence into the void of space for about a century. Radio and television broadcasts, powerful radar installations, and our communication networks are spreading outward at a speed of hundreds of thousands of kilometers per second. These electromagnetic waves expanding at the speed of light form a massive man-made sphere within the galaxy. Today, the radius of that invisible sphere has reached approximately 100 light. Every star 100 light-years away from Earth has been bathed in our radio broadcasts. If there are advanced civilizations orbiting those stars capable of detecting radio signals, they must know we are here right now. However, this distance we call 100 light-years remains nothing but a microscopic dot against the mind-boggling dimensions of the Milky Way. The distance from one end of our galaxy to the other is about 100,000 light-years. In this ocean of trillions of kilometers, our signals have only managed to touch a tiny drop of water around our own planet. We have only been able to whisper our existence to our immediate next-door neighbors so far. Moreover, this whisper is gradually losing its strength. The inverse square law, which applies to light, operates with the same ruthlessness for radio waves. When you double the distance, the strength of the signal drops to a quarter. When you triple the distance, it drops to a ninth. By the time our old television broadcasts reach a star 50 light-years away, they become extremely faint, weak, and completely indistinguishable from the background noise of space. To detect those signals, massive radio telescopes tuned to precisely the right frequency at exactly the right time would have to be looking directly at Earth. The probability of this happening by chance is almost non-existent. In light of all these physical limits, perhaps we can say that there are civilizations out there somewhere. Perhaps they just haven't noticed us yet, because we are too quiet or not close enough to them. However, this doesn't explain why we still cannot detect them. If our galaxy hosts thousands or millions of advanced civilizations, some of them must have been making very powerful broadcasts, intentionally or unintentionally. Some should have been close enough for us to hear, and some should have been advanced enough for us to see the massive signatures of their technology. But when we look at the horizon, all we see is a deep nothingness. To explain this silence piercing the heart of the Fermi paradox, scientists have proposed dozens of different hypotheses. Some of these solutions are optimistic, some are pessimistic, and some are extremely terrifying. Let's slowly peel back the dark blanket of space to make sense of this deep slumber of the universe. One of the most promising explanations brought to this deep silence where the Fermi paradox echoes is the rare Earth hypothesis. This view proposes that, while simple, single-celled life forms might be extremely common in the depths of space, complex life where intelligence can sprout is extraordinarily rare. When we look closer at this pale blue dot called Earth, we see that our planet is a combination of extraordinarily lucky coincidences, as if it had won a cosmic lottery. Our existence relies on a fine-tuning that cannot be explained solely by our distance from the Sun. Our Earth has a massive satellite that prevents extreme climate fluctuations and stabilizes our axial tilt. Without the Moon's gravity, our planet would wobble chaotically in space. Seasons would be dragged into destructive irregularity, and it would become impossible for complex life to hold on. We are in the orbit of a star, whose energy output is extremely stable. Our Sun is a calm and long-lasting energy source that doesn't scorch its surroundings with deadly radiation storms. We must also not forget the presence of our giant neighbor Jupiter, acting like a cosmic vacuum cleaner, warding off dangers heading toward the inner solar system. Its massive gravity creates a safe zone for us by attracting or deflecting comets and asteroids that would constantly bombard our planet. Without Jupiter, every evolutionary step on the Earth's surface could have been repeatedly reset by devastating fireballs raining from the sky. It doesn't stop there. We have plate tectonics that regulate the chemical structure of our atmosphere over geological timescales and maintain the carbon cycle. This mobility on the surface acts as a massive thermostat that preserves the planet's temperature balance and prevents the oceans from evaporating or completely freezing over. Deep within, we have a molten iron core that produces a strong magnetic field protecting us from harmful solar radiation and cosmic rays. Without this invisible shield, our atmosphere would be stripped away into space by solar winds, and our planet would turn into a dry, radiation-soaked desert, just like Mars. The lack of any of these enumerated features might not prevent the evolution of simple life forms. However, the combination of all these complex conditions may be absolutely necessary for the development of multicellular thinking and feeling beings. If planets possessing all these features simultaneously are incredibly rare in space, then intelligence must be equally unique. If this hypothesis is true, the galaxy we observe might be alive, full of simple cellular organisms, but mentally completely empty and silent, while the rest of the universe is trapped in a bacterial level of existence. We incredibly luckily leaped toward intelligence on this mind-boggling biological track of billions of years. If everything depends on this chain of fine-tuning, the Great Silence is not a paradox, but an inevitable consequence of nature. Earth might be the only place to win the jackpot of the cosmic lottery. The trillions of star systems around us are barren worlds that haven't yet rolled the right dice to create a thinking structure like ours. Our existence is the result of such a hard-won victory and a unique combination. The silence in the sky might not only be a sign of our loneliness, but also that another world as lucky as ours hasn't emerged yet. Unfortunately, this hypothesis also opens the door to darker and more dangerous questions waiting for us. Because the universe is an unpredictable evolutionary laboratory that not only creates the right planet, but constantly tests the life on it. Surviving requires continuously passing through arduous exams. While trying to make sense of our unique position presented by the rare Earth hypothesis, we encounter a much deeper and philosophical concept: the Great Filter. Somewhere along this long journey from inanimate matter to an interstellar civilization, there is an extremely difficult and almost impossible threshold. This is such a massive barrier that it eliminates almost every species that reaches this stage of the evolutionary process, pushing them out of development and erasing them from the process. The real question we should ask, the one that makes our spines shiver, is exactly where this filter is. If this massive wall is in our past, this is one of the greatest pieces of good news we could ever hear for humanity. It means we have long surpassed the most difficult evolutionary step. We have passed that relentless test, where the vast majority of other potential life in the galaxy gets stuck. Perhaps the transition from inanimate chemicals to the first, self-replicating molecule was a mind-bogglingly rare event on a universal scale. Perhaps the universe got stuck at the point where genetic codes spontaneously organized to form the first cell, even if it had the right heat and water. In this case, Earth is that unique lucky spot among billions of star systems where this biological miracle occurred. If you want, let's look further. Perhaps that great filter was hidden in the transition from single-celled, simple organisms to multicellular complex life forms. When we examine Earth's history, we see that this possibility is not unfounded at all. Life on our planet appeared quite rapidly shortly after the surface cooled enough to hold liquid water. However, this life maintained a single-celled, microscopic, and stagnant existence for billions of years. It took about 3 billion years for nature to change that simple design and for cells to come together to form complex structures. Throughout this massive time span, Earth was a silent, primitive planet consisting solely of bacteria and archaea. The emergence of plants, animals, and moving body plans that we are familiar with today occurred only within the last 600 million years. With that sudden evolutionary leap, called the Cambrian explosion, fish filling the oceans, land plants greening the continents, and ultimately the arrival of insects, reptiles, and dinosaurs on the stage were events that happened only on the final pages of the universal calendar. If the transition from single-cellularity to multicellularity hasn't happened for billions of years on other planets in the universe, this could be that massive filter we left behind. Our galaxy might be overflowing with microbes, but these life forms never turn into a tree, an animal, or an intelligence that can look at the sky and think, let's consider an even more specific possibility. Perhaps the evolution of intelligence is one of those terrifyingly rare exceptions that happens 1 in a billion. Dinosaurs were the rulers of the planet for 165 million years, yet they never learned to use fire or make tools. We mammals, back then, were small, insignificant creatures, hiding in their shadows. That massive advantage we call intelligence might not even be strictly necessary for long-term survival. In nature, many species can survive highly successfully simply by adapting to the environment, reproducing, and multiplying. Large brains are extremely expensive in terms of energy. They require long childhoods, social structures, and knowledge transfer. If intelligence is not an inevitable outcome of evolution but a random deviation, then that insurmountable filter we left in the past is intelligence itself. If this is the case, we can take a deep breath. We passed that relentless sieve. We took those impossible steps. Our future is potentially limitless. Our horizon is wide, and the stars are laid out there entirely for us to explore. The dark and silent universe might be full of lifeless planets of beings who weren't as lucky as us, and couldn't pass that filter. However, if we reverse the equation, this philosophical relief will quickly be replaced by a freezing terror. Because what if the great filter is not behind us, but standing right in front of us? This is exactly where the chilling part of the great filter hypothesis lies. What if the reason for the silence in the universe is not that life is rare, but a dark destiny inherent in the nature of intelligence? If the filter is not behind us but in front of us, This means a relentless guillotine falling upon every civilization. According to this scenario, planets sprout life, species evolve towards intelligence. They build civilizations, develop their technologies. However, just as they are about to open up to the stars, they hit a mysterious and insurmountable wall and are destroyed. At this point, the silent universe ceases to be a puzzle to be solved and turns into a whispering harbinger of our approaching end. If every intelligent species prepares its own apocalypse after crossing a certain technological threshold, our loneliness in the galaxy and the nothingness our radio telescopes here become extremely logical. So what could this deadly test be that confronts every civilization and from which no one comes out alive? When we look at the destructive powers humanity has invented over the last century, finding the answer to this question unfortunately doesn't seem too difficult. The potential extinction scenarios we face lie in the dark shadows of those technological leaps that are the products of our intelligence. First of all, let's look at the destructive potential of nuclear fire. We have a nuclear arsenal capable of making our own planet completely uninhabitable. The bombs that wiped cities off the map at the end of World War II look like mere sparks compared to today's modern thermonuclear weapons. Massive firestorms, triggered by a full-scale nuclear war, clouds of smoke and ash covering the atmosphere, could cause a nuclear winter that blocks sunlight for years and collapses agriculture. Such a disaster would not only condemn billions of people to starvation, but also bury the entire progress of our civilization into an irreversible darkness. However, the threat is not only hidden in split atoms, but also in the genetic codes we play with. The giant steps we've taken in biotechnology and genetic engineering carry tremendous potential for curing diseases and improving our quality of life. But the same technology also puts the power into our hands to create engineered pathogens deadlier than anything nature has produced so far. A weaponized virus that spreads rapidly, is resistant to all available treatments, and targets only a specific species could wipe humanity off the face of the earth silently and swiftly. This might be a less noisy but much more certain end than a tuller nuclear explosion. Then there is the awakening of artificial intelligence. We are on the verge of building systems that learn on their own, improve themselves, and ultimately surpass human intelligence manifold. If the goals of these superintelligent algorithms conflict with our existence, it is very difficult to foresee what will happen. An out-of-control AI that sees humanity as an obstacle or merely as a resource to be consumed might calculate that removing us from the equation is the most efficient way to reach its goals. If we also give this intelligence the power to manipulate the physical universe, the gray goo scenario, where autonomous machines turn the world into a synthetic copy, could be an inevitable end. Beyond all of this, we are already in the grips of a silent and slow destruction. Climate collapse. We are changing the atmospheric balance of our planet at an unprecedented rate in history. The greenhouse gases we pump into the atmosphere, melting glaciers, acidifying oceans, and changing precipitation regimes are not just warming the Earth. They are dragging our life support systems to a point of no return. If we push the system beyond that delicate tipping point, a runaway greenhouse effect could turn our planet into an uninhabitable, scorched desert. Here is the most terrifying thought. Perhaps the universe is so silent because beings reach this threshold and then destroy themselves. The inevitable byproduct of advanced technology might be the self-termination of intelligence. Perhaps we are right in the middle of our great filter, we just don't realize it. Cosmic silence is not a mystery. It is the universal and absolute proof questioning the permanence of intelligence. Will we be able to make that massive transition that no one else has managed? Or will we add our own silence to this great muteness? One of the most chilling and perhaps most convincing solutions to the Fermi paradox is the dark forest hypothesis, a dark blend of sociology, game theory, and cosmic uncertainties. If the great filter is not civilizations destroying themselves, then we must turn to an even more sinister possibility to explain why space is so desolate. What if the universe is much more crowded than we think? but no one dares to reveal their location. To understand this hypothesis, you must cast your mind beyond the stars and imagine the universe as a massive forest. Imagine you are walking in the depths of a dense and dangerous forest in the dead of night, where you can only see a few steps ahead. You know that there are others walking in the shadows of the trees around you, sharing the same darkness with you. You don't know who they are, their intentions, what kind of weapons they carry, or how hungry they are. Just as you cannot see them, they cannot see you. Right in the middle of this unnerving unknown, what would you do if you heard a branch snap or a whisper very close to you? Would you shout with joy and give away your position? Or would you hold your breath, crouch down where you are, and cloak yourself in absolute silence? The dark forest hypothesis builds the survival strategy of civilizations in the galaxy precisely on this cold logic. The mind-boggling dimensions of interstellar distances make it impossible to communicate and instantly weigh intentions. When you receive a signal from the depths of space, you can never know whether the intelligence behind that message is peaceful or destructive. You do not have the luxury to test whether a species that has managed to leave its own solar system and spread into the galaxy believes in universal peace and philosophy. You can only understand a civilization's intention when their ships appear in your orbit, or when a deadly weapon is about to strike your world. And when that happens, it is already too late for everything. This is exactly why the most rational, safest, and most certain survival strategy for any intelligent being in the universe is to hide. Every civilization that announces its presence to the universe, emits radio waves, or draws attention by building massive engineering structures around its star, essentially becomes a massive bull. Resources are limited in this infinitely expanding space, and sooner or later, a competition between civilizations wanting to expand to different systems is inevitable. If you discover the existence of another species you will potentially compete with, would you give them the opportunity to develop, grow stronger, and become a threat to you in the future? According to dark forest logic, no, you wouldn't. The safest way is to destroy any potential threat you detect in the fastest and most ruthless way, before they turn into a real threat. The one who attacks first always has the highest chance of survival. If this is the case, this ruthless cosmic law divides civilizations in the galaxy into two distinct groups. On one side, there are the master hunters, who have learned silence, hiding, and surviving. On the other side are the naive victims who, without understanding how dangerous the universe is, joyfully shout, reveal their locations, and are destroyed in a short time. This hypothesis perfectly explains that deafening silence we feel every time we look at the sky. We believe space is empty because all we hear is nothingness. However, the galaxy might be filled to the brim with intelligent life. There might be civilizations holding their breath in billions of star systems, masterfully hiding the heat and light signatures of their own planets. Each one is scanning radio waves, each one is listening to the sky, but none of them ever sends a signal that would reveal their own location. They are all hiding in their own dark corners, lying in ambush to deal a deadly blow to the slightest sound that appears on the horizon. And if this dark forest scenario is true, the silence of the sky does not mean an emptiness, but a highly conscious and terrifying vow of silence. Faced with this cold logic of the dark forest hypothesis, when we look back at the signals and messages humanity has launched into space over the last century, we confront an incredibly chilling reality. We are practically like little children shouting with joy in this silent and dangerous forest of the universe, completely unaware of the presence of the hunters around us. With that deep and naive belief that the sky is a friendly and welcoming place, we enthusiastically shout our own location and identity to the depths of the universe. Our scientific curiosity and our desire to satisfy our loneliness may have blinded us to the reality of what a huge danger we are putting ourselves in on a cosmic scale. Imagine, in 1974, we sent an intentional message towards the globular star cluster named Messier using the massive Arecibo radio telescope in Puerto Rico, designed by Frank Drake and Carl Sagan. This message was humanity's first big and conscious hello to the universe. Composed of 1679 binary digits, when decoded, this message included an image of the Arecibo telescope itself, a simple drawing of the human body, a map of our solar system, the double helix structure of our DNA, and our counting system. This message will travel for about 25,000 years to reach its destination. If there is a civilization in that distant cluster that will receive our message and reply, it will take another 25,000 years for their response to reach us. Considering that civilizations can rise and fall within these massive timeframes, we understand very well how fragile our attempt to communicate is. But we didn't just settle for radio waves either. We also sent physical envoys into the interstellar void. The Pioneer 10 and 11 spacecraft launched in 1972 and 1973 carry GoldenEye's aluminum plaques. These plaques feature depictions clearly showing where our planet is and who we are. Designed like a cosmic map giving the location of our solar system relative to 14 other pulsars, these directions are practically an open address for any intelligent being looking to find us. Pioneer 10 has long left our solar system and will pass near the star Aldebaran in the Taurus constellation in about 2 million years, taking an even bolder step. We launched the Voyager 1 and 2 probes in 1977. Each of these vehicles carries gold-plated copper records containing the diversity, cultures, and sounds of our planet. Music from different cultures, greetings spoken in 55 languages, thunder, wind, whale songs, and hundreds of images of life on Earth are drifting toward eternity inside these silent envoys. Engraved on the records is also that familiar pulsar map indicating the exact location of our planet. Voyager 1 is currently traveling towards interstellar space, billions of kilometers away from Earth as the farthest man-made object. Even when our own sun turns into a red giant and swallows our planet approximately 5 billion years later, these vehicles and the messages inside them will continue to float in the darkness. The only physical evidence left of us will be these silent envoys. All these efforts were made under the assumption that the civilizations finding our messages would be friendly, curious, and well-intentioned. However, if the dark forest hypothesis is true, these envoys and messages could be the most dangerous, most deadly mistakes humanity has ever made. These maps and ID cards we sent with good intentions could turn into shining target points on the radars of cosmic hunters. We personally handed our biology, our intelligence, and most importantly, where we live, to them with our own hands. This naivety of ours is the clearest indicator that we have failed to grasp the actual reason for the silence in the universe, and that we have violated the survival rule lying behind that deafening muteness. Perhaps the silence in the sky is the clearest warning telling us that we must learn to be afraid in contrast to the wild and destructive nature of the dark forest. There is another scenario that explains the silence in a much more isolating, controlled, and equally chilling way. The zoo hypothesis. If there are civilizations that have passed the great filter, spread to the stars, and chosen a different path instead of destroying each other in the dark forest, perhaps the reason for the silence is their conscious decision. This hypothesis proposes that space is actually extremely crowded, but advanced intelligences, intentionally and with very strict rules, avoid making contact with primitive species like us. While we believe space is empty, we might actually be living right in the middle of a massive cosmic quarantine, in a nature reserve surrounded by invisible walls. Let's think about our behavior on Earth. For example, when we observe natural habitats, we do our best not to disrupt the natural behavior of the animals there. Not interfering with the development of creatures living in a wild forest or on an isolated island, and allowing them to find their own paths, is one of our most fundamental ethical rules. To protect a population that might carry a disease or an ecosystem that is extremely vulnerable to external influences, we quarantine them and cut them off from the outside world. The zoo hypothesis assumes that civilizations millions of years ahead of us are doing exactly this. If there is a massive civilization or a federation of civilizations in the galaxy that has normalized interstellar travel and learned to manipulate energy, in their eyes, humanity is still in its infancy stage. To them, our nuclear weapons, our pollution of our planet, our endless wars, and our primitive biology might make us a highly dangerous, unstable, and aggressive species. Perhaps they are observing us, collecting data about us, but never making their presence felt. Just like how we only study isolated tribes in the rainforests from afar, and avoid landing a helicopter in their world. In this case, Earth is simply a protected zone surrounded by an invisible tape, where entry and exit are forbidden. Why don't they communicate with us? Because we haven't crossed a certain developmental threshold yet. This threshold could be a technological leap. For instance, we might be expected to discover near light speed travel. Or it could be a much deeper criterion. We might be required to successfully become a single, peaceful, global civilization without destroying our planet and killing each other. Perhaps they are silently waiting to see if we can pass this test. If we destroy ourselves, this will simply be recorded in the ledger as the failed result of an evolutionary experiment. In one aspect, this hypothesis is quite comforting, because it whispers that the universe is not that dark and ruthless forest. But on the contrary, intelligent life is protected, and we are safe. However, the other side of the coin is extremely disturbing. What are their criteria? What will happen when we pass that secret test they've set? Will they suddenly descend from the sky and invite us to a massive galactic community? Or have we actually already failed that test and they are just waiting for the result to reach its conclusion? The idea that our entire existence, our beliefs, our history, and our science is just a documentary or a closed laboratory experiment watched by beings billions of years smarter than us completely shatters human hubris. However, the weakest point of the zoo hypothesis is also here. We have to assume that every single civilization in the galaxy, every rebel, every different faction follows this strict non-interference rule flawlessly. It seems highly illogical that across trillions of planets and over billions of years, not a single civilization has broken this rule, landed on Earth, or sent a signal. If there was even a single disruptor, that silence would be broken. The flawless silence of the sky indicates either that these rules are enforced with an unimaginably absolute power, or that, in fact, no one is watching us. If no one is watching us, the reason for the silence might not be hidden in the vastness of space, but in how civilizations evolve, and ultimately what they turn into. As we navigate through the darkness where the Fermi paradox echoes, we also need to clearly define what we mean when we say an advanced civilization. Because if we don't know what the thing we are looking for in the sky looks like, our chances of finding it drop to zero. This is exactly where that famous scale introduced by Soviet astronomer Nikolai Kardashev in 1964 comes into play. Kardashev proposed measuring the developmental level of civilizations, not merely by the technology they possess or their cultural accumulations, but by the magnitude of the energy they use. This mind-boggling and eye-opening classification radically changes our perspective on the universe. According to the Kardashev scale, a Type 1 civilization, the first step is a civilization that can fully control and use all the energy falling on its home planet with 100% efficiency. A species at this level has absolute command over the power of the wind, the waves of the oceans, geothermal leaks, and every single photon arriving from the sun. It can alter its planet's climate, direct volcanic activities, and manage its atmosphere like a flawless thermostat. The Type 1 level means ceasing to be a species that bows to the whims of nature and becoming the actual manager of the planet. So, where does humanity stand on this scale, you ask? The answer is quite modest. We are not even Type 1 yet. Our level, achieved by burning fossil fuels and spinning wind turbines, is around 0.7. However, if we take the right steps, it seems possible for us to cross that first great cosmic threshold within the next few centuries, when we move to the second step of the scale. The Type 2 civilization. Things start to seriously push the boundaries of science fiction. A civilization at this level no longer settles for the meager energy crumbs falling on its planet. It sets its sights directly on that massive nuclear furnace in the sky, its own star. A Type 2 civilization completely captures and utilizes the entire energy output produced by its home star. Our own sun produces about 3.8 xyd watts of power per second. Imagine a species that can completely control this mind-boggling amount of energy. What can be done with such immense energy? For a Type 2 civilization, changing the orbits of planets, making dead worlds habitable, terraforming or building giant computers the size of star systems, becomes an ordinary engineering project. They can vaporize asteroids threatening their planets and steer their own evolution in any direction they desire. A species that has reached this stage is not a passive spectator of nature, but the architect of the cosmos itself. They have practically achieved godlike power in their own solar systems. But what really strains our minds is what a Type 3 civilization can do. A civilization at this level commands not just a single star, but its entire host galaxy. They have access to billions of stars, countless planetary systems, and the energy of the supermassive black hole at the center of the galaxy. The artificial structures of a Type 3 civilization are spread across the entire galaxy, and a massive communication and transportation network is established. They might have built interstellar highways stretching across light years, information networks wrapping all planets, or systems that even use dark matter as an energy source. Their technology, when evaluated with our current understanding, would seem like pure magic. Here, the painful contradiction of the Fermi paradox stands before us again. If the universe granted a massive amount of time, like billions of years, for the evolution of intelligence, some of them should have already reached the Type 2 or Type 3 level. Civilizations using energy on such a massive scale, turning galaxies or stars into engineering projects, should have left massive traces behind them. Such immense power could not be invisible. But why can't our telescopes see even the slightest spark left by these godlike builders in the galaxy? If the upper steps of the Kardashev scale are possible, what is the emptiness of the sky trying to tell us? Perhaps the way to achieve this immense power is through locking stars in cages. We said that a civilization that has reached the Type 2 level on the Kardashev scale has the ability to completely command the energy of its own star. But how will they achieve this? The most reasonable way for an advanced civilization to bring this massive nuclear furnace under control is a theoretical structure proposed by Freeman Dyson in 1960, the Dyson sphere. A Dyson sphere is a giant artificial cage that completely or partially surrounds a star, capturing the immense energy it radiates into space and making it available for the civilization's use. Of course, this structure doesn't have to be a solid, monolithic shell entirely trapping the star. In fact, physically building such a massive and fragile structure is near impossible. Instead, a Dyson swarm consisting of millions or billions of independent solar panels orbiting the star is a much more logical engineering solution. This massive army of collectors absorbs the star's photons, meets the mind-boggling energy needs of the civilization, and turns them into a powerhouse on a cosmic scale. If there is a Type 2 civilization somewhere in the universe, and it has built a Dyson sphere or swarm, such a massive structure cannot remain invisible in space. Dictated by the immutable laws of thermodynamics, a portion of this gathered immense energy must inevitably be radiated into space as waste heat. Therefore, while a Dyson sphere largely blocks the star's visible light, it will emit a strong infrared radiation, meaning heat, into space. Then, when we look at the sky with our advanced telescopes, we should look for stars that are dim in visible light, but anomalously bright in the infrared spectrum. Astronomers have been chasing these artificial signatures, these techno-signatures, for years. They scanned hundreds of thousands of galaxies in the sky, hoping to find unusual infrared emissions or unnatural stellar spectra. Most of the time, the anomalies they found turned out to be dust clouds surrounding young stars or the remnants of asteroid collisions. However, Tabby's star KIC 8,462,852, located about 1280 light-years away from us in the Cygnus constellation, presented the scientific world with a mystery that shook it deeply. The Kepler Space Telescope monitored the brightness of this star continuously for years during its planet-hunting mission. What it observed was completely different from the regular and tiny, around 1%, light dips of planetary transits. The light of Tabby's star was dimming at completely irregular intervals and by massive proportions, up to 22%. Even Jupiter, the largest planet in our solar system, can only block about 1% of the sun's light when it passes in front of it. There was no known natural planetary model that could explain these massive and chaotic dimmings in Tabby's star. What could be the thing blocking the light so irregularly and in such large proportions? Among the natural explanations proposed were a fragmented massive swarm of comets in the star's orbit, or the debris cloud of a planetary collision. However, no natural model fully satisfied the observed data. It was at this point that an incredible whisper began to circulate within the serious and conservative walls of the scientific world. What if what we are observing is a massive Dyson swarm currently under construction? What if the thing blocking the light is the massive solar panels of that advanced civilization? Increasingly accumulating data and more detailed analyses weakened the megastructure hypothesis and made natural explanations more likely. Yet, this event taught us a very important truth. Even the slightest unexplained anomaly is enough to immediately trigger that deep "are we alone?" question inside us. We are so hungry to find traces of intelligence that we have an extreme tendency to attribute every incomprehensible dark spot to alien engineering. Even if Tabby's star isn't a Dyson sphere, it served as a perfect laboratory, showing us exactly what we should be looking for and how to look beyond the horizon.